Welcome back, Ms. Butler's class. This is session 3, Refine Ideas about Categories of Two-Dimensional Figures. So that's a long title / kind of target for us. So in easier words, we're just going to say we are organizing shapes based off of their characteristics. So we're looking at the shape's attributes. So for example, do they have parallel lines? Do they have right angles? Do they have equal size? Those type of things. And we're going to use our Venn diagrams and tree diagrams to help us visually organize and understand those relationships. So for example, a rectangle and a square are similar because they got parallel sides. They got 4 right angles, but they're different because a square has equal lengths and a rectangle does not. Okay, so we are going to go ahead and move to our pose a question today. So your question is when are times that you might organize shapes in real life? And with this question, I want you guys to think about it by yourselves first, and then I'm going to pick who is going to answer. So I'll give you an example of a time that Miss Butler might organize shapes in real life. I always tell you guys the refrigerator example. So Miss Butler is making sure she puts the cheese with the cheese and the apples with the apples. That way my refrigerator looks aesthetically pleasing and it looks organized. So that's our goal, is to organize our shapes today. So the person I'm going to pick to start the conversation is number 3. So number 3, you'll start, and then we'll go 1, 2, and 4. Okay? Go ahead and talk. Please pause the video while I am waiting on you to finish your conversations, and then press play, and we'll go ahead and talk about the next question. Okay, so some examples that some of you might have came up with for how you organize shapes in real life are like in your bedroom when you're organizing your books or toys, or you might be organizing in the kitchen when you're filling up the dishwasher. Trying to think of some other ways that you could have organized, but I'm pretty sure you guys have some great ideas. So we're going to go ahead and move on to our activity, our start question of always, sometimes, or never. So for this activity, I want you to take a moment and think on your own first, and then I'll give you time to talk with your groups about if you believe this is always, sometimes, or never. So for example, you have the question, a square is a parallelogram. So this statement right here, is that true? Is it always true? Is it sometimes true? Or is it never true? And then so on with the other one. So go ahead and think about that by yourself first, and then I'll go ahead and give you guys some time to talk about it. Okay, so I had wrote on the other sheet because my video was kind of acting up, so I'm going to redraw your squares real quick. All right, 1, 3, 2, and 4. All right. So, the person I'm going to have start the conversation is number 2, and you're going to answer A. Number 4 is going to answer B, 3, C, and 1, D. So you're just going to go in order, okay? So number 2, so you're starting first. Is a square always a parallelogram? Always, sometimes, or never. And then we'll continue on. Go ahead and pause this video. When you're done with the activity, go ahead and press play, and I'll move on. Okay, so this is just kind of your answers over here. I kind of already wrote them ahead of time, so I'll review them. A square is a parallelogram. That is always true. And it's always true because a square has 2 sets of parallel sides. And because it has 2 sets of parallel sides, that makes it a parallelogram. A quadrilateral is a rectangle. And that's sometimes true because a quadrilateral is just a shape that has 4 sides. So that could be a square, that could be a rhombus, that can be a parallelogram, that could be a diamond, but it can also be a rectangle. So that's why it's sometimes true. C, a pentagon is a quadrilateral. And the answer to that is never, because a pentagon is a shape that has 5 sides. So it will never be a quadrilateral. And D, a rhombus is a square. And a rhombus is similar to a square because it has parallel sides and 4 equal sides, but a rhombus does not have to have 4 right angles. So sometimes a rhombus could have 4 right angles because it is a square, but a square could be a rhombus, but a rhombus does not have to be a square. All right, so we're going to go ahead and go to this apply it problem. I'm going to do this one for you, and I just need you to listen because this one was very kind of confusing how they worded it. So I want to make sure that you guys are understanding. So I was in the middle of drawing the shapes in my last video and then my video kind of just died. So I'm just going to try that again. So I was kind of talking about how a regular polygon is a shape that has all sides of equal length and all sides of equal measure. But there is 2 shapes that don't necessarily always have to follow these rules, and then there's 2 shapes that do follow these rules. So I want you to figure out what are the 2 shapes that are most similar. Okay, so these are your 4 shapes. You have a square, pentagon, equilateral triangles, and hexagons. So please go ahead and look at that, pause the video, and then think about which 2 do not actually fit this rule all the time and which 2 do fit this rule all the time. Okay, so I'm going to go ahead and explain this one because I said I would explain this one so you guys can move on in this activity. So the 2 shapes that don't actually fit this rule of a regular polygon has to have all sides of equal length and all angles of equal measure are pentagons and hexagons. So an equilateral triangle, it's in the name of an equilateral triangle that it has to have equal sides and it has to have 3 sides, sorry, because it's a triangle. And so that one will always have to follow the rule. There's no way out of that. The other shape, there's no way out of it, is a square. The square has to have the 4 right angles. It has to have equal sides and it has to have 4 sides. So because it has to have those 4 right angles, the only way a square can be shaped like a square is if it's shaped like this. So there's no other way to change the way a square looks. Now a pentagon, a regular pentagon can definitely fit this category, but there is such thing as irregular pentagons where the shape might look something more like that. And then same thing for hexagons, the shape may look something like this. Okay, so obviously those sides are not all equal length and the angles are not. So the shapes that are most similar in this case would be equilateral and a square. That does not mean a square and an equilateral triangle are the same. They are just very similar in this way that they have to have these specific shapes because of all the attributes that these shapes have. Okay, we're going to go ahead and move on to number 2. So number 2 is showing a picture of a tree diagram, and it's showing a picture of a Venn diagram. Okay, and we just want to know, is Kamama correct? Is she correct with the way that she designed these? And then you're going to explain yes or no. So you can put yes, or you're going to put no. Okay, and then you're going to explain why. Okay, I'm going to give you a couple seconds. Please pause this video. When you are ready to continue, please unpause the video and I will explain. All right, thank you for trying this problem by yourself. So the answer is yes, Kamama is correct in the way that she drew out these tree diagrams and her Venn diagram. So first of all, both of them show that the overall categories are triangles. And then we're going to split our triangles into subcategories. So we have the scalene and the isosceles. Scalene means no equal sides. Isosceles means at least 2 equal sides. And then we have the equilateral triangle, which means it has to have 3 equal sides. So this is our most specific triangle, So the more we are towards the center or towards a subcategory, then we're showing that that this is the most specific triangle. So both diagrams are showing the same thing. I'll go ahead and read what it says for the response. It says equilateral triangles are a subcategory of isosceles triangles because they have at least 2 sides of equal length. Scalene triangles have all sides of different lengths, so they cannot be isosceles or equilateral. Both diagrams show these relationships. All right, we're going to go ahead and move on to number 3. Number 3 is just asking, what is a shape that's both a rectangle and a rhombus? Okay, go ahead and pause this video, answer this question, draw the shape right here, and then unpause the video so you can see the answer. All right, thank you guys for trying this problem by yourself. So, rules about rectangles. Okay, rectangles must have parallel sides. Okay, rectangles must have right angles. Okay, and they must have 4 sides. Now, for a rectangle, it has unequal sides. Okay, and now a rhombus must have 4 equal sides. Okay. So a shape that I know that has 4 equal sides, right angles, and parallel sides, just like my rhombus and my rectangle, the only shape that should come to mind is a square, because squares have equal sides like my rhombus. Squares have parallel sides like my rhombus and my rectangle. And squares have right angles just like my rectangle. So therefore, your shape you should have drawn was a square. Okay, my video is about to stop in just a moment. So I want you to go ahead and try number 4. There is a shape on here that does not really go with this tree diagram. It doesn't make any sense. So I hope you can point it out by yourself. That will be your exit ticket for today, and then you're allowed to get on iReady. So please check in with your sub to see if you can find out what shape does not fit the tree diagram, and you need to be able to explain why. Okay? So you have the polygons, quadrilateral, pentagons, rectangles, and parallelograms. What shape does not match this tree diagram? All right, remember, once you're done, you can get on iReady, MyPath, and then you can work on Fluency Flight. Thank you guys for working so hard and paying attention during this lesson. And I hope you guys have a good rest of your day. I will see you when I get back from my interview. All right, bye. Have a good rest of your day.